Hello and welcome to another GCSE Maths walkthrough, and this is the final paper in the 2023 series, which is paper 3, and that's the calculator paper. And this video will be for foundation tier, but I have also got a higher tier video. Now, I've taken this paper from Maths Genie, so many thanks to them for providing the paper. And I've left a link in the video description which will take you straight to the paper. So if you click on that link, you can download the paper, have a go at the questions yourself, and then you can compare your answers with my workings out from this video. And one last thing, just before we get started, is that I have created chapter headings, which is always useful because if you struggle with a particular topic, you can just click on that chapter heading and that will take you straight to a question that focuses on that particular topic. So I think I've covered everything, so with that all out of the way, let's get started. Question 1, write down two factors of 20. Now, the way I like to write down factors is first of all start with 1, because 1 is a factor of any number. So 1 times 20, that will give us 20. And actually, we're done. We've found two factors of 20, 1 and 20. So I can just write 1 and 20 as my answers. Let me just show you what other factors we could have chosen. So after 1, we can go on to 2. Is 2 a factor of 20? Well, yes, 2 is definitely a factor of 20 because it's even. And 2 times 10 is 20. Is 3 a factor of 20? No, 3 is not a factor of 20. You can always check this on the calculator. You could do 20 divided by 3. And notice you get a decimal. So 3 is definitely not a factor. But 4 is a factor. And 4 times 5 is 20, and now we're done because after 4 is 5, but we've already checked 5. So once we've done that, we can stop. So there are 6 factors of 20, but as I said, we only need 2. So as soon as you've done 1 and 20, you can just put those as your answers. Question 2, write 40% as a fraction. So what does the word percent mean? Well, this symbol here, percent, I'm just going to write it down, percent. Now this is key, this word here, cent means 100. So cent is just another word for 100. So if we've got 40 per 100, we can just write that down as 40 over 100. So that's what this means. So we have written it down as a fraction. So that's our answer, 40 per 100. We do not need to simplify this. Okay, we can simplify, so I can just pop that into the calculator. So 40 over 100, and nicely for us, the calculator will simplify it for us. So if we did need to simplify, just use the calculator. You don't need to sort of do any other calculations yourself manually. Just type it in, press equals, and notice it simplifies it. So 40 over 100 is the same as 2/5. But we don't need to simplify. So we can just leave our answer as this. Question 3. Write down a 6-digit number that has a 7 in its hundreds digit. You can only use the digit 7 once. Okay, so we're going to write down a number. It's got 6 digits. So let's just do our 6 digits. 1, 2, 3, 4, 5, 6. And it has a 7 in its hundreds digit. So this is the units digit. I'm just going to write U under here. This is the tens digit, and this is the hundreds digit. So we know there's a 7 here, and we can only use the digit 7 once. So we can just write anything in these numbers here, as long as we don't use the digit 7 again. So, you know, I could write 1, 2, 3, 2, 1, for example. There's sort of a lot of different combinations you can use. You can put any numbers in here. So obviously your answer that you've got is probably different to my answer. But as long as it fulfills the criteria, that's absolutely fine. So I've got 123,721. So that is a 6-digit number. It has 7 in the hundreds digit. And I've only used the digit 7 once. So that would be a perfectly acceptable answer. Question 4. Write 78.54 correct to one significant figure. So let me just write down the number down here. 78.54. Now, when we're rounding to one significant figure, we look at the first digit. If that's not 0, well, that is definitely significant. So this is our first significant figure, the 7. So what I do is I'll just put a dashed line here. Now we look at the 8. So if this number is less than 5, we would round down. But if it is greater than or equal to 5, we would round this up. So because this is greater than 5, we would round this up to an 8. So we would round this up to an 8, and then everything else would be 0. So it would be 80.00. But we don't need to include those 2 zeros at the end. So our answer is just going to be 80. And our answer is 80. A lot of people make a mistake and just think, well, that changes to an 8, so my answer is just going to be 8. But no, you can't just lose all of the place values that we've got. So it would either round down to 70 or up to 80, and in this case you can see that it rounds up to 80. Question 5. The graph shows some information about car production in the UK over 8 years. So we've got the year along the x-axis and the number of cars produced on the y-axis. Part A, for how many of these years was car production more than 1.6 million? Right, let's look at our graph. So 1.6 million is here. So if we go along, no, 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 yes, yes, no, no. So these two are greater than 1.6 million. So how many years? So it's 2 years. It's not asking us for the years, so it's going to be years 5 and year 6. It's not asking us for the years, it's asking us for how many of these years. So it'll be 2 of those years. Okay, part B. In which 2 years was car production the same? Right, let's look at our graph again. So you're looking for two years where it's the same, and I think I've spotted it. So I can see that this here, year 7 is 1.5 million, and year 2 is also 1.5 million. So this time we do need to give the years. So year 2 and year 7. Question 6. There are 3 cards in bag A, and there are 2 cards in bag B, and there's a letter on each card. Ali takes a card from bag A and then a card from bag B. List all of the possible outcomes. So whenever you're asked to list things, always try to think systematically about it. And what I mean by that is do it in a particular order. So don't try and just do it randomly. So first of all, I'm going to start with all the C's. So let's say that Ali takes a C from bag A and then an F from bag B. So that's one combination. Let's say he still takes a C from bag A, but then he takes a G from bag B. Now that's all of the C combinations, CF and CG. Now let's look at the D combinations. So you can have D and F, and you can also have D and G. And that's all of the D combinations. And now finally let's look at E. He can have EF and EG. So EF and EG. And that is all of the different combinations. And notice we've got 3 in bag A and 2 in bag B. The total number of combinations you should have would be if you just multiplied them together. So we've got 3 here, 2 here. So we should have 6 combinations in total. And you can see that we have got 6. So we have done it correctly. Question 7. On Monday, Lucy pays for 2 plane tickets, 7 nights in a hotel, and 2 theme park tickets. And we've got the prices here. Show that Lucy pays more than $2,500 on Monday. So we've got 2 lots of plane tickets. So it's going to be 2 times 750. So let's work out that. So 2 times 750, and we get 1,500. She spends 7 nights in a hotel, so it's going to be 7 times the cost of a night in a hotel, which is $120. Let's work out that. 7 times 120. That's $840. And finally, she buys 2 theme park tickets. So 2 times the theme park ticket cost is $125. And I can do that in my head. That's just $250. So the total amount she pays, we're going to have to add all of these up. So we've got 840 here, plus 1,500, plus 250, and we get $2,590. So show that Lucy pays more than $2,500. Well, we have done that. 2,590 is definitely more than 2,500, and we could just write 2,590 is greater than 2,500. I don't think we need this, but just sort of showing the examiner that we can tell that this number is greater than 2,500. And after just saying that, I think it probably is best to include this, because if you just include this, you're only saying how much she pays. So I think it's probably best to verify and confirm that it is more than 2,500 here. Question 8. Solve this equation. Right, let me just copy down the equation underneath. So we've got y over 5 is equal to 6. Now, at the moment, we're dividing by 5. We want to get y on its own, so we need to do the opposite. So the opposite of dividing by 5 is multiplying by 5. So we need to multiply both sides of our equation by 5. On the left-hand side, well, the 5s will just cancel out. We'll only be left with y. That's the whole reason why we've done it, is to get y on its own. And on the right-hand side, 6 times 5, well, that is 30. So my answer is y equals 30. Okay, let's look at part B. And again, we're going to solve... Oh, wrong colour. We are going to solve this equation. So I'm going to write down the equation again. So we've got 2f minus 9 is equal to 12. And our goal is to get f on its own. So the first thing I'm going to do is get rid of this minus 9. And to do that, I'm going to do the opposite. So I'm going to add 9. And I'm obviously going to do that to both sides of my equation. We can't just do it to one side. We have to do it to both sides. So I'm just going to be left with 2f is equal to 12 plus 9 is 21. And now finally, we want to get f on its own. At the moment, we're multiplying by 2. So to get f on its own, we need to divide by 2. So we divide both sides by 2. And we're left with f is equal to 21 divided by 2. Well, that is 10.5. So our answer is f is equal to 10.5. Question 9. Here is part of a train timetable. Rosie gets to the station in Brighton at 07:15. Work out how many minutes she has to wait until 07:22. Right, so you can see that the hours are exactly the same. It's 7 o'clock in the morning, but she gets to the station at 15 minutes past 7, and she has to wait until 22 minutes past 7. So to work out how long she has to wait, we could just do 22 minus 15. And 22 minus 15 is 7, so she only has to wait 7 minutes, not too long. Right, let's have a look at part B. Work out how long it will take the 07:22 train to get to London. So we are looking at this train here. So the 07:22 train, it leaves Brighton at 7:22 and it gets to London at 8:50. So how long does she have to wait? So let's write this down. So she leaves at 07:22. Now, the way I like to do this is, first of all, how long did it take to get to 0800? So 8 o'clock. So to go from 7:22 to 8 o'clock, how long does that take? Well, there are 60 minutes in an hour. So we just need to do 60 minus 22. And that gives us 38. So it takes 38 minutes to get to 8 o'clock. And now let's go from 8 o'clock to 8:50. So 08:50, and this is a bit easier. We can see it takes 50 minutes. 50 minutes. So in total, how long does it take? Well, we just need to add these together. 38 plus 50, well, that will give us 88 minutes. Now, in the question, it doesn't say whether to give your answer in minutes or hours. So this is exactly the same as 1 hour 28 minutes, but I'm just going to leave it in minutes because, you know, we don't need to do anything else. So I'm just going to put in here 88 minutes. And we're done for this question. Question 10. Adam, Beth and Charlie share an amount of money in the ratio 6 to 7 to 8. What fraction of the money does Charlie get? So we've got this ratio here. So what we do when we're calculating what fraction of an amount someone gets is, first of all, we calculate how many parts there are in total. So we just add these together. So 6 plus 7 plus 8, and I can see that will give us 21. And how many of those parts does Charlie get? Well, because Charlie's the last name, he gets 8 parts. So it's always done in order of name. So Adam would get 6, Beth would get 7, and Charlie would get 8. So Charlie gets 8 out of the total of 21. So he gets 8 parts out of 21 parts. So that is our answer. 8 out of 21. Question 11. Cornflakes are sold in 2 sizes of box, so small and large. Sophie buys 4 small boxes of cornflakes and some large boxes of cornflakes. In total, she buys 4,328 grams of cornflakes. Work out the number of large boxes of cornflakes Ray buys. I think that's basically Sophie buys, because we've got Sophie and Ray. So let's have a look at this. So she buys 4 small boxes of cornflakes. Now we know the size of the small box, they're 540 grams. So we can do 4 times 540. So 4 times 540, that gives us 2,160 grams. And now it says in total she buys 4,320 grams of cornflakes. So to work out how many grams are left over, we can just subtract this from 4,320. So if we do 4,320 subtract 2,160, so 4,320 minus answer, that was my previous answer, and well, I also get exactly the same. So she buys the same amount in terms of weight for both small and large, 2,160 grams. Now it's asking us for how many boxes that is, not the amount. It's not asking us for the weight of the cornflakes. It's asking us for how many boxes. So each large box is 720 grams. So we're just going to divide this by 720. So 2,160 divided by 720. So I'm just going to divide my answer by 720. And that's nice to see we've got an integer. We get 3. So our answer is 3 boxes. I can just write 3 here. So whenever you get an answer that's an integer, that's what you're looking for, because obviously you can't have 3.5 boxes. I'm sure the supermarket doesn't allow you to cut a box in half and take it to the checkout. So yeah, for this question, you should be looking for an integer answer. Question 12. Here is a number machine. So we've got an input. We put a number in here. We divide by 8, then we add 4, and out pops our answer. So it says work out the output when the input is 48. So we're going to put 48 as the input. So we're going to put 48 into our number machine. Then we're going to divide by 8 and then plus 5. So we're going to do 48, divide by 8, and then we're going to add on 5. There we go. So I'm just going to, well, I could put this into the calculator, but I think I'm just going to do this in my head. 48 divided by 8 is 6. 6 plus 5 is 11. So our answer is 11. Okay, let's look at part B. Here is a different number machine. The number machine is not complete, which we can see here. When the input is 6, the output is 168. Complete the number machine. Right, okay, we're going to have to work a bit backwards for this one. So our input is 6 and our output is 168. So for this question, we're going to be working backwards. So my output is 168. Now notice I'm multiplying by 12 to get my answer. So to go backwards, I'm going to do the opposite and divide by 12. So I'm going to do 168 divided by 12. So 168 divided by 12, and that gives me 14. Okay, so that gives me 14. So whatever we've got before here, so let me just box this. So all of this must equal 14, because we know that 14 times 12 is 168. So now we've got 6, we're putting 6 into the number machine, we're adding something, and we're getting 14. So again, we're going to be working backwards. So to work out what our missing number is, we're going to subtract 6. So I'm just doing the opposite. So we're going to do 14 minus 6, and that will give us 8. So our answer is 8. And you can see that makes sense because 6 plus 8 does give us 14. Because we're looking for 14 here, because we know that 14 times 12 is 168. So notice for each part, I just worked backwards. I did the inverse operation. So I don't think we need to write any answers down here. It just says complete the number machine. So we just need to put 8 into the box. Question 13. Complete the table of values for y equals a half x minus 1. Now, when you've been asked to complete a table of values, there is a tool on your calculator that will enable you to do that. So at the moment, you'll just be in the standard calculate mode. If you press menu, here you can see you're in calculate mode. But if you go to number 3, you can just type in 3 or you can scroll along to 3. You can see it says table mode. So if you press equals, now you can enter your equation into the calculator. So we don't need to put y equals, that's already there. All we need to type in is this part here. So a half x minus 1. So we put in a half and now x. Now the button for x is this red x here. Okay, so it's none of these x's that you usually use for squared and other things like that. So to get this red x, you press alpha and then close brackets. You can see it's got the x there, and then just minus 1. So that's our equation. Don't worry about this. This is just if you type in another equation. We've only got one equation, so you just need to press equals. And now we just need to type in the start and end points. So we're starting at -2. So if we type in -2 equals, we're ending at 3. So type in 3 equals. And the step, that just means what are we going up by each time. And we can leave that as 1 because you can see we're going up by 1 each time. So press equals and it gives you the table of values. So just be really careful now because we're reading down here, but here we're reading across. So it's all been flipped. So just be careful about that. But you can see that when x equals -2, y equals -2. So when x equals -2, y equals -2. When x equals -1, y equals -1.5, which we've already got, so we know this is correct. When x equals 0, y equals -1. When x equals 1, y equals -0.5. And then we just need to scroll down. So when x equals 2, y equals 0. And if we scroll down once more, when x equals 3, y equals 0.5. So we've completed our table of values. The other way to do that would be just to type it manually in the calculator. So first of all, I will do that, but first of all, I need to get out of table mode. So if you have gone into table mode, to get out of it, if you press the menu button again, and then scroll back along to calculate and press equals, you're back to normal. So obviously we don't want you staying in table mode for the rest of the exam. It's really important that you're in the standard calculate mode. So just to show you the other way you could have done this. So what you could have done is in your calculator, you can type in a half and then the value for x and put that in brackets. If you put the value for x in brackets, so -2, if we're starting at -2, and then -1, and then equals. So we type in a half and go along and then type in -2 in brackets, -2. So that just means a half times -2, and then -1. We press equals, you can see that we've still got -2. Now we don't need to type in the whole expression again. All we need to do is if we press the right arrow key, go back to where it says -2, just delete that and put in -1. Press equals and you get -1.5. And then you can just keep doing exactly the same thing. Get rid of -1. Press 0, press equals, you get -1, and you can just keep doing that. So delete 0, put in 1, press equals, and you get a -0.5, or -0.5, and you can keep doing that. So if you're not confident with using the calculator, and if you're a bit worried about using the table mode, I suggest you just do this method here, where you just type in the expression into your calculator, and then you're just substituting the value in brackets for all of these values you've been given. That's probably the safest way to do it. Okay, now let's look at part B. It says on the grid, draw the graph of y equals a half x minus 1 for values of x from -2 to 3. So all we're doing now is plotting these points on our graph. So if we start with the first one, -2, -2. So along the corridor and up or down the stairs. So -2, -2 is down here. -1, -1.5, that will be here. 0, -1, that will be here. 1, -0.5 is here. 2, 0 is here. And 3, 0.5 is here. So you can see that we've got a nice straight line. So let me get my line tool out. So we've got a nice straight line. I'm going to make that a bit thinner. That is way too thick. So that's a bit better. And I'm just going to extend it. I would always extend it to the edge of our graph. So make sure you do that. Make sure you don't just stop at the point. Okay, so don't stop at these endpoints. Make sure it goes all the way to the end of the graph and even off the graph if you just to be safe. So that is part B. Now let's look at part C. So let me get my highlighter back out. Use the graph to find the value of x when y equals 0.2. So we need to look at our graph when y equals 0.2. Well, this is our y-axis. Now 0.2, this is 0, 0.1, 0.2 is here. So I'm going to draw another line on where y equals 0.2. So that is y equals 0.2. Let me just change the colour just so you don't get confused with our original line. So what is the value of x? Now, you need to be really careful here because this graph isn't the biggest, so your graph, if you printed it out, will be a bit easier to see. But I can see that it's this point here. Let me get my pencil. So it's this point here. So that is the point we're looking at. If this is 2, 2.1, 2.2, 2.3, 2.4. So our answer is 2.4. Now we can check our answer. It does take a bit of extra work and it requires a bit of rearranging formulae, but we can check our answer. So what we can do is we can rearrange this formula and make x the subject. So let me just write down the original formula down here. Y equals a half x minus 1. So we want to get x on its own. At the moment we're subtracting 1. So if we add 1 to both sides, we've got y plus 1 is equal to a half x. And now we want to get x on its own. So at the moment we're multiplying by a half. So to get rid of this fraction, we can just multiply both sides by 2. So on the left hand side, we'll be left with 2 times y plus 1. And on the right hand side, we'll just be left with x. So notice it says find the value of x when y equals 0.2. So we can just substitute this value for y into our equation and it will give us the value of x. So let's do that on the calculator. So we've got 2 in brackets y plus 1. Well, we know that y is 0.2, so it's going to be 0.2 plus 1, close brackets. Then if we press equals and then change it to a decimal, you can see that we've got 2.4. So we've got it exactly right. So obviously this requires a bit more work, and you can't just do this working out. To get your answer, if you just do this working out, you won't get the mark. Because in the question it says, where it says down here, it says use your graph to find the value of x. So you have to use the graph. This was just a check, basically. Question 14. A group of football fans were asked what their half-time snack was. The table below gives some information about their answers. You can see here that 31 fans had a burger, 28 fans had a pie, and 13 fans had a hot dog. We need to draw an accurate pie chart for this information. Now, I don't have the printout, so I'm going to struggle a bit. I will try and do it as accurately as possible, and I'm going to put my protractor on the screen to help me. So you obviously will need a protractor for this particular question. So the first thing to do, I think, is to work out how many fans there are in total. So I'm just going to sum all of these numbers together. So we've got 31 plus 28 plus 13. So let's type that into the calculator. 31 plus 28 plus 13. That gives us 72. So there are 72 fans. Now, to work out the angle for each sector, we know that there are 360 degrees in a full circle. So to work out what each fan is worth, So the degree for each fan, we just need to do 360 divided by 72. So 360 divided by 72, and that gives us 5. So if we just stop and pause and think about what this means that each fan is worth 5 degrees. So let's write that down. Each fan equals 5 degrees. So now we can work out what each sector is going to be. So if there are 31 burger fans, or 31 fans who had a burger, we can just do 31 multiplied by 5. For the pie section, we can do 28 times 5. And for the hot dog section, we can do 13 times 5. So let's first of all do 31 times 5. That gives us 155 degrees. So that is what our sector is going to be worth. Now let's do 28 times 5. And we get 140 degrees. And finally, 13 times 5. Or no, not 135. 13 times 5. And we get 65 degrees. Now, if we've done this correctly, they should sum to 360 degrees. So let's just check that. 155 plus 140 plus 65. And indeed, we get 360 degrees. So I'm quite confident that we've got the right sections here. Right, so now let me put my protractor on the screen. And I'm going to put the cross of my protractor in the center of the circle. So just bear with me for this. And I'm going to line up the 0. And I'm going to mark off 155 degrees, which is down here. There we go. That's obviously not going to be perfect. You just heard my protractor falling there from the screen. So let me get my line tool out and draw a line from here down to there. There we go. And now what I'm going to do is I'm going to put my protractor on where I've just drawn that line, basically. Just going to line up the cross at the center and 0 on the red line. And now I'm going to measure 140 degrees, which is, let me get my pen back out. 140 is here, I believe, for me. So let me get my line tool out and draw another line. It's a bit cumbersome, this question for me, but I think I've done it correctly. So let's just label, now we need to label our sectors. So this biggest one here, this is the burgers. So burger, and I'm just going to say what, so this is, what is that, 155 degrees. And now this one here was the pie, and that is 140 degrees. And finally, we've got the hot dog section, which is 65 degrees. Question 15. A shop sells compost in 40-litre bags and 50-litre bags. One day, the shop had 2 special offers for compost. So these are our special offers. The 40-litre bag, you can get 3 bags for £20, and for the 50-litre bag, you get 2 bags for £16. Which offer is the best value for money? You must show how you get your answer. Okay, so how much does it cost with the special offer? So first of all, let's look at this one here, the 40-litre bag. You get 3 bags for £20. So if each bag is 40 litres, well, we can do 3 times 40, and that will give us 120 litres. So you get 120 litres for £20. I think, let me just write that down over here. 120 litres is equal to £20. And now let's do the 50-litre bag. I'm going to use red for this one. So you get 2 bags for £16. So to work out the number of litres, we can just do 2 times 50, and that will be 100. So that's 100 litres. So for this bag over here, you get 100 litres, and you're going to be paying £16. Now at the moment, it's quite hard to compare which one's cheaper because we have different sizes. So although this one's cheaper, you get a smaller bag. So we're going to have to find a value for the number of litres which is the same. So what is a factor of both of these numbers? Well, 10 goes into 120, and 10 also goes into 100. So if I can work out 10 litres, the cost of 10 litres for this bag here. So how would I do that? Well, I can just divide by 12. So to go from 120 to 10, I'm dividing by 12. So if I do exactly the same over here, if I divide by 12, so 20 divided by 12, and that gives us, or it gives us a recurring decimal. So if we just round this to the nearest penny, well, it's going to be £1.67. So £1.67 for 10 litres. If we do exactly the same for this one up here, so to work out 10 litres, well, this time I'm going to be dividing by 10. So divide by 10. So if I divide this side by 10, and I don't need a calculator for that, well, that's going to be £1.60. So £1.60. So these are our kind of two bits of information that we're going to look at. So for the black bag, which is the smaller one, you get 10 litres for £1.67. For the bigger one, you get 10 litres for £1.60. So that's clearly cheaper. So this one is better value for money. The 50 litre is better value for money. So which offer is better value for money? I could say the 50 litre bag is better value for money. So that is, in brackets, I'm just going to put 2 bags for £16 because it's asking us which offer is better value. So the 2 bags for £16 is better value, and then I'm also just going to put in here £1.60 is less than £1.67. £1.67. There we go. And for this question, there's loads of different ways you could answer it. So you could have worked out 20 litres each. You could have worked out a completely different value, as long as you've found that when you're comparing them, you're comparing the same thing. Question 16. There are 800 students in a school. Each student has either a school dinner or a packed lunch. 33% of the students have packed lunches. 45% of the students are boys. 55% of the boys have school dinners. How many girls have packed lunches? You must show your working. Now, there is quite a lot of information here. Now, just to keep things structured, what I'm going to do is I'm going to put all of the information in a table. So we've got boys and girls. So boys and girls. And I'm going to do another column for total. And then the type of meal they're having, we've got a school dinner. I'm just going to put SD for short. And a packed lunch. And then I'm also going to put total here. So I'm going to make a large table here. And then just doing this, I think it's easier to keep track of all of the numbers. So it doesn't need to be neat. So let's put in all of the information that we do know. So there are 800 students at the school. So the total number of students is going to be 800 down here. So the bottom right, the total of the total. And 33% of the students have packed lunches. So we can work out the total number of people who have packed lunches by doing 33% of 800. Or we can say 33%, that's the same as 0.33. So 0.33 times 800. So 0.33 times 800. And we get 264. So 264 of the students have packed lunches. So packed lunch, the total, that will be 264. Now let's look at the next line. 45% of the students are boys. So out of the 800 students, 45% are boys. So we can do 0.45 times 800. 0.45 times 800. And we get 360. 360. Sorry, I should have written in the answer up here. So 360 of the students are boys. So total number of boys is 360. Now let's look at the next point. It says 55% of the boys have school dinners. Now we're not doing 55% of 800 because that will be 55% of the total. We're doing 55% of the boys, which we've just worked out. There are 360 boys. So 55% of them will be 0.55 times 360. So 0.55 times 360, and we get 198. So 198 boys have school dinners. 198 boys have school dinners. That's all the information we've been given, and now we can work out some of this, some of these blanks. So let's just highlight which one we're trying to work out. So how many girls have packed lunches? So girls pack lunch, we're working out this one here. So first of all, we can work out the number of boys who have packed lunch. We can do that because if we know the total and if we know the number who have school dinners, we can just subtract this one from this one. So if we do 360 minus 198 minus 198, so 360 minus 198, that gives us 162. And now we've got this number, we can work out this number by, again, doing the total. So this is the total number of people who have packed lunch minus the number of boys who have packed lunch. So it would be 2, again, I'm forgetting to write in the answers up here. So 162. So it would be 264 minus 162. 264 minus 162. And we get 102. So 102. So that is our answer because that's the one we're trying to work out. So our answer is 102. And just before I go on to the next question, I think hopefully you can see how much easier it is if we've got a grid. Okay, because if we've got all of this information, it can get a bit confusing if we're just trying to do lines of working out. But if we've got it in a grid, everything is nice and structured. So it's up to you if you do it like this. This is called a two-way table. So if you want to use a two-way table, that's absolutely fine. If you've got another method, then just go with that, whatever's easiest for you. Now for question 17, you'll notice that this display looks completely different to all of the other questions that I've been going through. And that is because I've had to take the question and put it on a website called MathsPad, which will allow me to do constructions. So for this question, you will need a pair of compasses. So question 17, A, B and C are 3 points on a map, which we can see here. 1 centimetre on the map represents 100 metres. Point T is 250 metres from point A, and point T is equidistant from point B and point C. And the question says, on the map, show one of the possible positions for point T. So we need to draw in point T on the map using this information. Now the first thing I'm going to look at is the scale. So I can see 1 centimetre represents 100 metres. And we're told that point T is 250 metres from point A. So we can work out how far away point T is from point A on the map by using the scale. So let me just change, let me get rid of my compass first of all. So I'm just going to change to red. So to convert from our real life measurement to our map measurement, we just need to divide by 100. So notice how I'm just going to divide by 100. So we're going to do 250 divided by 100, and that gives me 2.5, and that is 2.5 centimetres. So I know that point T is 2.5 centimetres away from point A, but I don't know in which direction. So if this is 2.5 centimetres, it could be over here, but it could be over here, it could be over here, it could be over here. So what I'm going to need to do is I'm going to get my compass out and measure 2.5 centimetres, and then I can just draw a circle around A, and then I'll know that point T will be somewhere on that circle. So if I just get rid of those points, so I'm going to measure, well, first of all, let me get my compass out and then put it on A. So I'm going to measure out 2.5 centimetres now. So it was already on A. So 2.5 centimetres. So I just need to first of all unlock this. So 2.5 centimetres will be there. Now if I lock it in place, get rid of the ruler, and I'm going to draw a circle around A. So circle around A, there we go. So get rid of the compass now. So now I know that T is somewhere on this circle because every point on this circle is 2.5 centimetres away from A. Now I'm going to look at this second point, and for this I'm just going to change the colour to a blue, I think. I don't get confused. So I'm going to use blue now. Point T is equidistant from point B and point C. So we know it's going to be somewhere sort of along this line here because it's equidistant from B and C. So for this, I'm going to get my compass out again. I'm going to put it on point C. Now for this, we need to extend our compass. So let me unlock it. We need to extend our compass so it's just over halfway. So if this is, so we've got C and B, it should be just over halfway. So let's just say about there. And what I'm going to do, let's lock it in place and just draw a circle around C. So a nice big circle around C. Now, I'm going to do exactly the same for B. So because I've locked it, we need to keep the distance exactly the same. So I'm just going to move the pin over to B, and I'm just going to draw another circle. So another circle like that. And the reason why we need to make it over halfway is so that we create a sort of an overlap. If your compass isn't over halfway, if it's under halfway, you'll get two separate circles. So it needs to be over halfway. So now let me get rid of the compass. Now notice there's 2 points of intersection. So this point here and this point here, they are both equidistant between C and B, because we know these compasses lines are the same. Okay, so this point and this point are exactly the same distance. Obviously this point is closer to C, this point is closer to B, but these 2 points are exactly the same. So what I'm going to do now is, if I get my line tool out, let's change the colour again. Let's make it fuchsia, just something a bit different. So I'm going to get my line tool out, or yeah, I'm going to get my line tool out, that's fine. Or should I get my ruler? Let's use the ruler instead. So I'm going to use the ruler, and I'm going to line it up like so. So I'm going to draw a line that fits perfectly. I'm going to try my best to get this as accurately as possible. There we go. And I'm going to draw a line that goes through those 2 points. So if I get rid of the ruler, you can see that this line goes through those 2 points. And notice it also hits these 2 points here. Oh. So this point here and this point. So anything on this purple line, or pink, anything on this pink line is equidistant between C and B. And anything on the red line is 2.5 centimeters from A. So what we're looking for is something that's on the pink line and the red line, and you can see that these 2 points here satisfy both of those. So on the map, show one possible position for T. So we could say this is T. So this would be one possible position for T. I'll just put T1. Or you could have used this one here, T2. So those will be both of the possible positions for T. Question 18. Tyrone buys a boat. The cost of the boat is £12,100 plus VAT at 20%. Tyrone pays a deposit of £5,000 and he pays the rest of the cost in 10 equal payments. Work out the amount of each of the 10 payments. Okay, so the cost of the boat, let's work out the total cost of the boat, because it's 12,100 plus VAT at 20%. Well, 20% of this, we can work out 20%. So, oh, not 2%. 20% is going to be 12,100 multiplied by 0.2. So 12,100 times 0.2, and that gives us £2,420. So that represents the VAT, or not VAT, VAT. So the total cost, well, it's going to be 12,100 plus 2,420. So we need to add on 12,100, and that gives us £14,520. So that's how much he has to pay for the boat. Now he puts down a deposit of £5,000. So we can subtract 5,000 from this. So we can do 14,520 minus 5,000, and that's going to give us £9,520. So he's already paid 5,000. This is how much he's got left to pay, and it says he pays the rest in 10 equal payments. So we can just divide this by 10. So we can do £9,520 divided by 10. That's nice and easy. That will give us £952. So that is our answer. That's how much he has to pay for each payment. So £952. Question 19. Here are the heights in centimetres of 15 plants. Draw a stem and leaf diagram for these heights. Now, a lot of the times the question will say draw an ordered stem and leaf diagram. I mean, it's not the case in this one, but I think what I'll do is I'll just do an ordered one, just in case you get one in your exam that says ordered. So usually it says ordered. Okay, if it doesn't say ordered, where you can just put the numbers in, they have to be in the right categories, but they don't necessarily have to be in order. But I'm going to put everything in order. So let's first of all look to see what the minimum and the maximum values are. So I think the minimum value is 15 and the maximum value, it will be 30 something, 34 I think. So in terms of the tens units, we're starting at 10. So I'm going to put a 1 here for the tens. So this is going to be tens and this is going to be units. So we've got tens, this would be 20, this will be 30, and I don't think there's any 40s. No, there aren't. So this is going to be my ordered stem and leaf diagram, but what I'm going to do is I'm just going to draw another one. So I'm going to draw another one just to put, first of all, put the information in. Okay, so 1, 2, 3. So what I'm going to do is I'm going to go through each of these and I'm going to tick them off as I go, just so I don't miss any. So the first one, 24, that will go there. So we've got that one. And then 22, 28. We've got another 22. We've got 15, 31, 23, 34, 30, then 25, then 16, and then 30, and then 15, and then 22, and then 31. So notice how I'm doing this, I'm making sure that I'm not missing off any. But you can see that it's not in any particular order, but now it's a lot easier just to put them in order. So if I focus on the tens, we've got 5. If I put this in order, it'll be 5, 5, 6. So 5, 5, 6. Now if we look at the 20s, we've got 2, 2, and 2. We've got 3 2s, 2, 2, 2. So let me just cross those off. 2, 2, 2. And then we've got a 3. And then we've got a 4. And then we've got a 5. And finally we've got an 8. So that's now in order. And now the final one, I can do 0, 0, 1, 1, 4. So now it's nicely ordered. And we need to make sure we put a key in. Sometimes this box won't be given to you. So here it's kind of giving you a bit of a hint that you need a key. But this won't always be given. But you do need to include it. So you can just pick a random number. So I'll just pick the first one. So 1, and then I'm going to put a line there and a 5. And you have to say what that means. So 1 line 5 represents 15 what? It's in centimeters. So 15 centimeters. So this key is really important because obviously if you didn't include this key, this is just a bunch of random numbers. So you need to include the key. So what I would recommend in your exam, if it doesn't say ordered, I would probably, well, I'm not sure whether you need to order it. It probably will say ordered if you do get a stem and leaf diagram, but I would just order it anyway, just to be on the safe side. So just do a sort of a trial one first, a sort of a sample, a sketch first. Once you've got that, then you can just transfer it over to the one that they've given you, the template that they've given you. Question 20. In April, Damala drove 480 miles in his car, and the car travelled 46.5 miles for each gallon of petrol used. We've got the petrol cost, £1.38 per litre, and we've also got a conversion from gallons to litres. So 1 gallon is 4.55 litres. Work out the cost of the petrol used in April. Okay, so he travelled 480 miles. And the car travelled 46.5 miles for each gallon. So we can work out the number of gallons used. Number of... Oh, that's a bad A. Number of gallons used by doing 480. So 480 divided by 46.5. 46.5. Because each gallon, that's how far he travelled. So 480 divided by 46.5, and we get a horrible recurring answer here. So I'm just going to leave it as a fraction, as a simplified fraction. So 320 over 31. So that's gallons. Gallons. Okay, now we've got a conversion, which is going to be useful because we need the petrol. The cost of petrol is in litres. At the moment, we're in gallons. So we need to convert gallons to petrols. Gallons to petrols? Gallons to petrol. Gallons to litres, sorry. So 1 gallon, let's write this out again. 1 gallon is equal to 4.55 litres. So if we've got whatever we've got, we need to multiply it by 4.55. So we need to do 320 over 31 multiplied by 4.55. And that will give us the number of litres used. So I'm just going to multiply it by 4.55. And we get an even more horrible fraction. So 1456 over 31. And that is in litres. So that's how many litres Damala used in his car. And now to work out the cost, we just need to multiply by 1.38. So the cost, we're going to take the amount of litres, so 1456 over 31, and we're going to multiply it by 1.38. 1.38. And again, you can write this as a decimal. I just like leaving them as fractions. But yeah, it's personal preference really. So now I'm going to multiply this by 1.38. Press equals, and I think now I'm going to convert it to a decimal because it's in pounds and pence. So I'm going to round it to the nearest penny. So that's going to be £64 and 82 pence because we're going to round up because of the 5. So £64 and 82 pence. Question 21. A is equal to 2 cubed multiplied by 3 squared multiplied by 5. And B is equal to 2 squared times 3 cubed times 5. Write down the highest common factor of A and B. So the first thing I'm going to do is I'm just going to rewrite these in full because at the moment we've got them in index form. So A is equal to 2 cubed, which is 2 times 2 times 2, times 3 squared, which is 3 times 3, times 5. And then B, well, that is equal to 2 squared, so that's 2 times 2, times 3 cubed, which is 3 times 3 times 3 times 5. So to work out the highest common factor, we need to look at what do they both have in common. Well, they both have a 2 in common, so we can write 2 down. They've both got another 2 in common, so they've both got a 2 times 2 in common. Now, they don't have any more 2's in common. Although A has got a 2, we don't have any more in B, so we can't multiply any more 2's. Now let's look at 3's. So we've got a 3 and a 3, so we can multiply it by 3. We've got another 3 in both numbers, so we multiply by 3 again. And again, we don't have any more 3's in common. So now the last one is 5, and I can see they've both got a 5 in common, so we're going to multiply by 5. So for both numbers, they both have a 2 times 2 times 3 times 3 times 5 in, just in slightly different orders. So that is our highest common factor. We just need to work out what this is. I could work this out in my head, but we've got a calculator, so why not use it? 2 times 2 times 3 times 3 times 5, and that gives us 180. So our highest common factor is 180. Question 22. Verity buys 12 bottles of apple juice for a total cost of £15, and then she sells all 12 bottles at £1.75 for each bottle. Work out Verity's percentage profit. So to work out a percentage profit, let's write this down. Percentage profit. Well, we take the profit that she makes. So we take the profit that she makes. That's just the difference between what she buys them for and what she sells them for. And we divide that by the original amount that she pays. So the original amount. And then because we're writing it as a percentage, this is only as a fraction, we would need to multiply this by 100. So what is the profit? Well, it's the difference between what she buys them for and what she sells them for. Well, she buys them for £15. We know what she sells each bottle for, so we need to work out the total amount that she sells them for. So 12 bottles at £1.75 each. We're just going to do 12 times 1.75. So 12 times 1.75, that gives us £21. So she sells them for £21. So the profit is going to be 21 minus 15. So it looks like she's made a £6 profit. And we're going to divide that by the original amount she paid. Well, she paid 15. And then we're going to multiply that by 100. So let's put that into a calculator. So I know this is 6 on the top. So it's going to be 6 over 15. And then I'm going to multiply that by 100. And I get 40. So that is 40%. Makes a 40% profit. So we just need to write in 40. We don't need the percentage symbol because that's already been given to us. Question 23. The table shows the populations of 5 countries. Work out the difference between the population of India and the population of Turkey. Give your answer in standard form. So India is this. That's the population of India. The population of Turkey is this one here. And we're working out the difference. So we're just going to do one, subtract the other. Now, from the powers, I can see that India is bigger, and that makes sense. India is more populated than Turkey. So I'm going to take the population of India, so 1.4 times 10 to the power 9, and I'm going to subtract the population of Turkey, which is 8.4 times 10 to the power 7. So let's type that into the calculator. 1.4 times 10 to the power 9, and I don't need brackets for this because of BIDMAS, this will do it properly. And then minus 8.4 times 10 to the power of 7. And that gives me a very long number. So let's write that whole thing down. 1316, and then we've got 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Now we're not going to write down this number. We need to give our answer in standard form. So our base number is going to be 1.316, and then we're going to multiply by 10. How many times? Well, if our decimal point is here at the moment, 1.316, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 times. That's going to be to the power of 9. Okay, let's look at part B. Given that the population of Iceland is 1 over k times the population of Denmark, work out the value of k. Give your answer correct to the nearest whole number. So let's write down what we've got. So, well, what countries are we looking at? We're looking at the population of Iceland, which is this population here, and Denmark, which is this one. So if we write down the figures, population of Iceland, so that's going to be 3.4 times 10 to the power of 5. That is equal to 1 over k times the population of Denmark, which is 5.8 times 10 to the power 6. So we've just got an equation here which we need to solve. At the moment I've got k in the denominator. I want to get k, I don't want k in the denominator, I want to get rid of this fraction. So what I'm going to do is I'm going to multiply both sides by k. So if I multiply by both sides by k, that will get rid of this k here. So on the left hand side, well, I'm just going to be left with 3.4 times 10 to the power 5, all of that multiplied by k. And on the right hand side, notice the k's will just cancel out. We've got a k in the denominator, k in the numerator. That's the whole reason why we're multiplying by k, is to get rid of it. So all we're left with is 5.8 times 10 to the power 6. And now, to get k on its own, we're just going to divide both sides by this here, what we've got in brackets. So k is going to be equal to 5.8 times 10 to the power 6, all of that over 3.4 times 10 to the power 5. So I'm just going to type this into the calculator. So we've got 5.8 times 10 to the power 6. All of that over 3.4 times 10 to the power 5. And we get a very long decimal. So I'm just going to write in the first few numbers, 17.058 ... And then we need to give our answer correct to the nearest whole number. So we can see that this is going to round down to 17. So k is 17. Question 24. The diagram shows the front of a wooden door with a semicircular glass window. Julie wants to apply 2 coats of wood varnish to the front of the door, shown shaded in the diagram. 250 millilitres of wood varnish covers 4 meters squared of the wood. Work out how many millilitres of wood varnish Julie will need. Give your answer correct to the nearest milliliter. So this is the door that she wants covering. So first of all, let's work out the area of the door that she wants covering. So to work out this shaded region, we're going to take the rectangle, the area of the rectangle, and we're going to subtract the area of that semicircle, and that will give us the area of the door. So the area of the rectangle, well, that's just going to be 2 times 0.75. That's going to be this here. And then the area of a semicircle, well, we're just going to calculate the area of a circle and then half it. Now, an area of a circle is pi r squared. Let's write that down. Area of a circle is equal to pi r squared. So it's just going to be half pi r squared. If I put that in brackets, it's going to be a half times pi times our radius squared. Now be really careful, because our radius is not 0.5. That's our diameter. Our radius is 0.25 because we need to half this. So it's going to be 0.25 squared. So let's put all of this into the calculator. We've got 2 times 0.75. That's the area of the rectangle. And we're going to subtract the area of the semicircle. So that's 0.5 times pi times 0.25 squared. Close brackets. And we get this answer here. I think I'm just going to round to 3 decimal places. So 1.402. 402. And that is in... Actually, let me round to... Well, I'll leave it like that. 1.0402 should be fine. And that is in meters squared. So let's make sure we've got our units in. Okay, now let's look at the next part of the question. It says 250 millilitres of wood varnish cover 4 meters squared of the wood. So let's write this down. 250 millilitres, that will cover 4 meters squared. Now we've got 1.402 meters squared. So 1.402 meters squared. We need to work out how much wood varnish that will require. Now I'm not going to go straight from 4 to this. First of all, I'm going to work out how much varnish we would need for 1 meter squared. So to do that, I'm just going to divide by 4. So to go from 4 to 1, I'm just going to divide by 4. So I'm going to do exactly the same here if I divide that by 4. So 250 divided by 4, that will give me 62.5. So 62.5 millilitres. And now I can work out how much we're going to need, because I can just multiply now by 1.402. So I'm going to do exactly the same to this side. So times by 1.402 times 1.402, and I get 87.625 millilitres. So that is how many millimeters we need to cover the front door, but that's not our final answer, because it says that Julie wants to apply 2 coats of wood varnish. So we just need to multiply this by 2. So we're going to do 87.625 times by 2. So just times that by 2. And we get 175.25 millilitres. So that is the total amount of wood varnish we need. Now it says give your answer correct to the nearest milliliter. So it's going to be 175 millilitres. Question 25. A, B, C, D and F, G, H, I are parallel lines. So that's these 2 lines here. BE is equal to CE. So that's these 2 lines, which we can see by the dashes. And angle BEC is 48 degrees. So all of this information has been provided to us on the diagram. We need to work out the size of angle JGH. So that is this angle here. And also, this is really important, we need to give a reason for each stage of our working out. So every time we work out an angle, we need to explain what we did to get that angle. So first of all, I'm going to start at the top here because we've got a lot of information. We can work out what this angle is. Okay, because notice that this is an isosceles triangle. So what I know about isosceles triangles is that base angles are the same. So this angle and this angle will be the same. And I also know that angles in a triangle sum to 180 degrees. So to work out this angle, first of all, I'm going to subtract 48. So I'm going to do 180 minus 48. So 180 minus 48. That gives me 132. And then because these are the same, I can just divide this by 2. So I can do 132 divided by 2. So just divide by 2. And I get 66 degrees. So 66. So we can say that angle EBC is equal to 66 degrees. And now we need to give our reasons. So remember, we need to give a reasons for why it's 66. I'm just going to do this in a different color. So I'm going to say that angles in a triangle sum to 180 degrees. That's what we did here. And the second thing we did was, the second thing we knew was that base angles of an isosceles triangle are equal. So I'm also going to put base angles in an isosceles triangle are equal. So that is my justification of how I got 66 degrees. Okay, now we can calculate this angle here. Let's do this in a different color. So this angle we can calculate, and that's because we've got a straight line. So we can say that angle GBC, well, that's going to be 180 minus this angle. 180 minus 66. So 180 minus 66, well, that will give us 114 degrees. So we've worked out what GBC is. We just need to give our reason. So the reason is that angles on a straight line, at a point. So at a point, you don't probably need that at a point, but I'm just going to write it in anyway. Sum to 180 degrees. So we've given our second statement. Now we're on to the final stretch, because now we can calculate this angle. There's a special relationship between these two angles, and they are corresponding angles. And what I know about corresponding angles is that they are equal. So angle JGH, that's what we're trying to work out. Well, that will also be equal to 114 degrees. And our reason is that corresponding angles are equal. So our answer, what we're going to put in on the answer line, is going to be 114. But notice, for each of these angles that I calculated, I gave a reason for my answer. And this is worth 5 marks, so it is worth a lot, and you will lose marks if you don't give these reasons. So these reasons that I've given are probably worth at least 2 marks, I would say. So make sure you include them. Question 26. ABCD is a trapezium. Work out the size of angle CDA. Give your answer to 1 decimal place. So first of all, where is angle CDA? Well, CDA, that is over here. So this is the angle we're trying to work out. Now, the first thing I'm going to do is, because this is a trapezium, if I were to drop a line from C all the way to the bottom here, I formed this angle, and this angle I know is a right angle. And the reason I know it's a right angle is because these two lines are parallel. So we've got a right angle triangle here. So we're trying to calculate this angle. If we've got some information about these side lengths, we will be able to calculate what this angle is. So we've got this length from A to D, and we've got this length B to C. If we can calculate this length from A to this point here, we can add these two together and take it away from 21, and that will give us this length here. So we've got enough information to calculate this length, and to do this I'm going to use Pythagoras. So Pythagoras' theorem states that I give these labels first of all, A, B and C. Remember, C is always the hypotenuse. So A squared is going to be equal to C squared minus B squared. Just be really careful. A lot of people will just add these together automatically, but because we've got the hypotenuse, we need to subtract. So A squared is going to be equal to 7 squared minus 5.6 squared. So let's put this into the calculator. 7 squared minus 5.6 squared. And that gives us 17.64, but that's clearly not this length. We need to square root our answer. So A is equal to the square root of 17.64. So square root answer, and we get 4.2. 4.2. So that's 4.2 centimeters. So now we can calculate this length. What we're going to do is we're going to do 21. Let's do it up here. So 21, take away the sum of these two lengths. So 4.2 plus 9. So 21 minus, in brackets, 4.2 plus 9. And that gives us 7.8. 7.8. So we know that this length is 7.8. Now, what else do we need? Well, we need this length here, but luckily for us, that's already been given because this is 5.6. Therefore, this is also 5.6. So now we've got these two lengths, we can calculate the angle, and we can use that using SOHCAHTOA. So first of all, let's just label our side lengths. What do we have? So if this is the angle we're interested in, this is the opposite. Actually, I'm just going to put op because that looks like it says 0. So that's the opposite, and this is the adjacent. So we're going to use SOHCAHTOA. Let me write down SOHCAHTOA. SOHCAHTOA. Now we've got the opposite and the adjacent. Which one of these trig functions involves the opposite and the adjacent? Well, it's the tan function. So we're going to be using tan. So the tan of our angle is equal to the opposite divided by the adjacent. So the tan of our angle, I'm just going to put tan of x, is equal to the opposite, which is 5.6, divided by the adjacent, which is 7.8. So to work out what x is, we just take the inverse tan. That would be tan negative 1. 5.6 over 7.8. So if I type all of this into the calculator, so it's going to be shift tan, because we're trying to work out what the angle is, and then 5.6 divided by 7.8, and then we'll close brackets, and we get 35.676 ... So that is the angle. And now it says, and it looks right, so always do that dummy check. So 35 degrees, that looks about 35 degrees. So I'm quite happy that that's the right answer, but we need to give our answer to 1 decimal place. So we're going to round up to 35.7. 35.7 degrees. Question 27, and you can see it is the last paper in the question, so you might be pleased about that. So we need to solve this quadratic equation. Now, when we're solving quadratic equations, we could use the quadratic formula, or we can factorise, and I can see, looking at these numbers, I think we might be able to factorise, which is going to be a lot quicker. So when we factorise, we need two numbers that multiply together to get 24. So I'm just going to do this in red here. So two numbers, so something times something is equal to 24. And those two numbers also have to sum together to get this number here, negative 11. So something plus something equals negative 11. So what two numbers are they? Well, if we think about all of the factors of 24, we could have 1 times 24, we could have 2 times 12, we could have 3 times 8, or we could have 4 times 6. So which of these pairs, when we add them together, we would get negative 11? Well, the 3 and the 8, we know that 3 plus 8 is 11, but we could also have negative 3 times negative 8. So as well as all of these combinations, we could also have negative 1 times negative 24. we could have -2 times -12, -3 times -8, and -4 times -6. Notice how when we multiply these together, because they're both negatives, they will also give us 24. So there are actually 8 different pairs we can choose from. Now, the ones that will give us a sum of -11 will be these ones here. Notice that if we've got, let's write this in, so -3 times -8 does give us 24. And if we've got -3 plus -8, that does give us -11. So what we do is to factorise this, we're just going to put them in a pair of double brackets. So the first one, we've got x minus 3. And the second one, we've got x minus 8. And obviously all of this here on the left-hand side, that's what we've got on the left-hand side. On the right-hand side, we've just got 0. Now, the key thing here is recognizing that whenever we multiply anything by 0, we always get 0. So if one of these is 0, so for example, if this here is 0, it doesn't matter what this is, our answer is going to be 0. Likewise, let's do it again, if this is 0, then it doesn't matter what's in here, we're always going to get 0. So one of these, at least one of these has to be 0. So either x minus 3 is equal to 0, or x minus 8 is equal to 0. And now we can just solve these two equations. So this one over here, x must be equal to 3. Notice 3 minus 3 is 0. Or x is going to be equal to 8. So we've got two different solutions here. So x is equal to 3 and x is equal to 8. So notice it doesn't matter which one of these we use. When x is 8, 8 minus 8 is 0. 0 times whatever this is, that will be 0. Or when x equals 3, 3 minus 3 is 0. It doesn't matter what this is. 3 times 0 is 0. So hopefully that made some sense. So this is our answer. You need both solutions to get all 3 marks. So we have now come to the end of the paper. I really hope that you found that useful. And if you do have any questions about the exam, please pop a comment in the comment section and I'll try and get back to you as quickly as possible. So thanks very much for watching and all the best for your final exams. Take care.